How would you approach a question of this very form? Remember that this question falls under compound experiments, and this is what we'll be looking at in this very lesson. If you have not subscribed to my channel, kindly subscribe for me. So we are saying that we have an unbiased die and a fair coin being tossed at once. We want to find the probability of obtaining all of these events. An unbiased die is a single experiment. A fair coin is also an experiment. When these two single experiments are combined, we have a compound experiment. How do we solve questions of this very form? So the first thing that we have to do is to write down the set of possible outcomes when these unbiased die and then the fair coin are tossed once. So we know that when we toss a die, we are going to have, so we have a die. When we toss a die, we are either going to get the number 1, the number 2, the number 3, 4, 5, or 6. Also, when we toss a coin once, we are either going to get a head or a tail. So when you combine these two experiments together, we get the compound experiment. So in listing the sample space, we can use the table method. We are going to use the first row to represent the toss of the die. So we have die, and then we are going to use this column to represent the toss of the coin. We know that these are the outcomes when we toss a coin once. So we have head and then tail, and then we are going to write this set of possible outcomes on this row. So after doing this, we are just going to pair the outcomes from the toss of the coin with the outcome from the toss of the die. So this is what we are having, head and then 1. So we have head and then 1. Then we have head and then 2. So we have H2, H3, H4, H5, H and then 6. Then move on to the tail side. We have tail 1, tail 2, tail 3, tail 4, tail 5, and then tail 6. So all these sets of possible outcomes in this arena or enclave become a set of possible outcomes when an unbiased die and then a fair coin are tossed once. So let's rewrite the sample space. H1, H2, H3, H4, H5, H6, then move on to the T1, T2, T3, T4, T5, and then T6. So we have a number of outcomes in the sample space. We are going to count them one after the other. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 outcomes in this compound experiment. So when we toss the die and then the coin, some of the outcomes can be a head and then the number 1. You can also get a tail and then the number 5. You can also get a head and then the number 6. Now our task is to find the probability of having a prime number and then a head. So we have this I So we have prime numbers and then a head. So we are going to use the letter, let's say G, to denote the event of obtaining a prime number and then a head. Then we look through the sample space, that is all the set of possible outcomes, to see if we can have a prime number and then a head. And we know what prime numbers are. They are numbers that have only two factors, the number itself and then 1. So we can have H2, 2 is a prime number, 3 is also a prime number, 5 is also a prime number. So we have H2, H3 and then H5. Prime number and then a head. So we have a head and then a prime number, a head and then a prime number, a head and then a prime number. So we are going to list these outcomes in these events. H2, H3 and then H5. Then we find the number of outcomes in these events. G, 1, 2, 3. So we have 3. Then we can proceed to find the probability of obtaining a prime number and then a head. So probability of obtaining a prime number and then a head is number of outcomes in that event all over the number of outcomes in the sample space. So we have 3 all over what? 12. We can break it down, right? 3 into 12, we have 1 all over 4. Very, very easy and then simple. Let's look at II. So with II, we are to obtain an even number and then head. So we have even number. Let's use the letter H to denote the event of obtaining an even number and then a head. So we have H. Then we look through the sample space or the set possible outcome for this experiment to see if we can get a head and then even numbers. And we know what even numbers are. They are numbers that are divisible by the number 2. So even numbers, we have 2 is an even number, 4 is an even number, 6 is also an even number. Then we look for a head. So we have head and then even number, head and then even number, head and then even number. So we are going to list all these outcomes. Head and then even number 2, head and then 4, head and then what? 6. So number of outcomes in this event, which is H, will be 1, 2, 3. So we have 3. Now once we have this, we can proceed to find the probability of obtaining an even number and then head will be number of outcomes in that event all over the number of outcomes in the sample space. So we have 3 all over what? 12. When we break it down, we are going to get 1 over 4. Very, very easy and then simple. Let's look at a score less than 3 and then a tail. So we are going to use the letter Y to denote the events of obtaining a score less than 3 and then a tail. So let's look through the sample space. So we have to first look for a tail. So we have T, 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 T. Then we look for a score which is less than the number 3. So it means we can have 1 and 2. So in looking for a number less than 3 and then tail, it means we are to look for the number 2 and then 1 and then a tail. So we have T1, T2. So a number less than 3 and then a tail, we have T1 and then T2. The number of outcomes in this event, we have 1, 2. So we can find the probability of obtaining a number less than 3, and then a tail, we have 2 all over what? 12. And that is going to give us 1 all over what? 6. Very, very easy. I will leave the last one for you to try your hands on it. A head and then a number greater than 2. Very, very easy. See you tomorrow. Bye-bye.